started?
Yes, sir.
For me.
Recording is about to start. Yes, sir.
Oh, okay, okay. So let's discuss first efficiency. In terms of technical terminology, what is efficiency? Can anyone define efficiency?
Efficiency means हम कितना इनपुट दे रहे हैं तो कितना आउटपुट हमें मिल रहा है.
Okay. हम कितने इनपुट पे कितना आउटपुट हमें मिल रहा है.
Yes, sir.
Okay. So basically it is a ratio of output to input. Okay. Correct?
Okay. Yes, sir.
Okay. So basically it's a ratio of output to input. And based on input, whatever output we are getting, based on that we can characterize this efficiency. And for reservoir, we know what is recovery. So does recovery and efficiency are same or different? What do you think?
मतलब somewhat same कह सकते हैं.
Yes, somewhat nahi. Jo overall recovery is 60%. That means whatever initial volume we had and whatever we produce from that, and we take the ratio of these two quantity, then we will get a recovery percentage. Like itna percent recovery hua hai. Efficiency means you can consider it as a separately as well as a combinedly also, but efficiency mostly किसका होता है? जैसे कि कोई equipment है तो उसका efficiency होता है. Okay, so ऐसे ही कोई method है तो उसका हम efficiency consider करेंगे, but it can recover based on that efficiency only. Like efficiency high है, that means recovery is high. But efficiency हम particular के लिए define करेंगे, जैसे कि हम यहाँ पे two kind of efficiency define कर रहे हैं. First one is the macroscopic efficiency. Macro efficiency, I think scope nahi hai. Macro efficiency. And second one is the micro efficiency. Okay. So let's suppose very basic example to understand these two terminology. And we know overall efficiency first. Displacement is a common term. Okay. So macroscopic and microscopic. Let's suppose this is our reservoir. Okay. And it has a volume of 100 meter cube. I am considering SI unit for now. Okay, actually our reservoir shape is never going to like this, but consider right now this is a reservoir with volume of, okay, no, don't consider right now volume, just understand this with area only. Let's suppose this is my surface of my room. Okay, ये मेरा सरफेस का रूम वो है, रूम का सरफेस है. ठीक है, जहां पे मैं बैठा हूं. एंड दिस हैज अ डायमेंशन ऑफ 2 × 3 मीटर. कंसिडर राइट नाउ इट एज अ मीटर. सो टोटल ओवरऑल एरिया मेरा बनेगा इससे 3 × 2 विच मीन्स 6 मीटर स्क्वायर. करेक्ट? ओके, इज इट करेक्ट? 6 मीटर स्क्वायर ही
Yes, sir.
बनेगा. ओके, नाउ let's suppose what I am doing, I want to clean my room. Okay, and I want to check what is my efficiency. In that case, what I do, uh, let's suppose whether I have cleaned this surface effectively or not. So I want to calculate efficiency. So I do one thing, I have a map with me and I want to clean my room using that map. So let's suppose I'm cleaning this room and my map is contacting with 4 meter square area. How much how much area does it impact? Only 4 meter square area. But with my map has its own efficiency, correct? लाइक मैप से मैं 4 मीटर स्क्वायर एरिया पे ही मेरा इफेक्टिवली वो पहुंच पाता है. 2 मीटर स्क्वायर एरिया कौन सा होगा बता सकता है क्या कोई इन रूम? यू नो यू हैव अ कबर्ट एंड ऑल थिंग्स जहां पे नीचे ये पहुंच नहीं सकता. देयर आर पॉसिबिलिटीज ना.
यस सर.
यस दैट मीन्स कि मैं 4 मीटर स्क्वायर पे ही इफेक्टिवली क्लीन कर रहा हूँ. बट अगेन मेरा जो मैप मॉप है वो पुराना है. ठीक है मेरा मॉप पुराना वाला है. तो विथ मॉप इटसेल्फ उसका भी थोड़ा बहुत इफिशिएंसी होगा. ओके सो फ्रॉम दिस 4 मीटर स्क्वायर मैं इफेक्टिवली 2 मीटर स्क्वायर ही क्लीन कर रहा हूँ. ओके जस्ट रिमूव दिस थिंग. इन टोटल एरिया कितना था अपने पास 6 मीटर स्क्वायर. उसमें से 4 मीटर स्क्वायर पे मैं रीच कर रहा हूँ. मेरा मॉप रीच कर रहा है और उस 4 मीटर स्क्वायर से मैं प्रोड्यूस कितना सॉरी मैं क्लीन कितना कर रहा हूँ एरिया. मैं 2 मीटर स्क्वायर ही क्लीन कर पा रहा हूँ. इसका ओवरऑल इफिशियंसी क्या होगा बेस्ड ऑन एरिया?
2/6 into
यस
100%.
करेक्ट. या ओके करेक्ट करेक्ट. 2/6 इज द ओवरऑल इफिशियंसी. ये क्या होगा ओवरऑल इफिशियंसी. Can I say that it is a multiplication of efficiency of this and this? Can I divide this into two parts? One is what is the efficiency based on whatever area contacted, and the efficiency based on the efficiency of that particular method or particular mode. Okay. So what is the efficiency for based on that first aspect? It is a 4/6. Okay. And based on second one 2/4, correct?
Yes sir.
And
Yes, sir. Yes, sir.
yeah, so there are two factors. One is based on the area contacted. Another one is based on the efficiency of that method only. इतना ही याद रखना है कि ये वाला जो इफिशियंसी है वो कितना क्लीन कर रहा है और ये कैसे क्लीन कर रहा है. ठीक है कितना एंड कैसे. सो यू कैन डिफरेंशिएट दिस टू. So this is nothing but this is just is a microscopic sorry correct me let me correct my bad. This is a macroscopic efficiency. And what is this? This is a microscopic. Scope इसका कम है means next scope पे हम देख रहे हैं. Okay, have you understood this properly?
Yes sir.
Okay, now let's move on to one more aspect of this. Let's suppose right now I don't want to clean my room, but I want to clean this volume. Okay, or let's connect it with directly to with reservoir. Okay, so let's suppose this is now my reservoir 100 meter. cube. Okay, so it how this 100 meter cube is calculated, it is simply multiplication of area and its height, or I can say yes, height only, correct? So
Yes.
let's suppose this is my area and this is my height. Okay, so can I write this area into height?
Yes.
Okay, correct, good. And now I can say that let's suppose इनिशियल वॉल्यूम है हमारे पास 3 कितना लिया है 100 मीटर क्यूब from this 100 meter square. Let's suppose whatever I am injecting or whatever fluid I am injecting or whatever method I am using is covering the area of, let's suppose, 80 meter cube. Okay, contacted area, I can say contacted volume, sorry, now it turned to contacted volume. Okay, before this, let me do one thing. This is 50 meter square and this is 2 meter. Okay, can I say that among this 50 meter square, yeah, from this 2, 15 to 2 is 100 meter cube. Total volume is 100 meter cube. How much is it injected? It contacted 80 meter cube or not 80, consider it as a 75. Contacted volume is 75 meter cube. Okay, but whatever fluid has contacted, it is not able to produce that entire volume, because we know water can push the oil but not completely. Okay, so among this contacted area, let's suppose final produced volume is 50 meter cube. Okay, so in these cases, can you tell me the value of microscopic efficiency? And generally, microscopic efficiency is represented by, I think, ED, and that macroscopic efficiency is represented by EV. Okay, this is notations which we have in our standard books. Okay, so this is macroscopic displacement efficiency, and this is macroscopic displacement efficiency. So just let me correct if this is not the case with standard books, but I am considering ED as a notation for a microscopic and EV is a notation for macroscopic. So tell me the value for ED and EV.
ईडी जो है वो होगा 50/100.
ED कितना होगा?
50/75 होगा ना.
Yes, 50/75 होगा, not 100. Okay,
और
because
ईवी
this is,
होगा.
yeah, EV अब तो पता चल जाएगा 75 divided by 100. So have you got idea what I want to say in this case?
यस सर.
Yes, sir.
Okay, so this is the intuition behind these two efficiencies. Later on, we will calculate directly using the formula, but you should know what does it actually mean. Then and then you can understand the actual formula. This is simply 3/4. This is simply 2/3. And we can say overall efficiency is nothing. And overall efficiency, I don't think there is any notation. Simple E we can represent EV and ED. We can say that, and it is simply 3/4 into 2/3 is equal to 50/100. Correct? And this value is 1 in all of the cases. Okay, so let me write the definition for this. This means uh, overall present से कितना contacted, and this is थोड़ा मिक्सअप हो रहा है ना. or it means फ्रॉम द कॉन्टेक्टेड. ओके, ये याद रखना, जितना कॉन्टेक्टेड था उसमें से फाइनल प्रोड्यूस. ओके. ओके, सो just remember these two definition, you can note it down. Okay, or I will share this file so you will have an idea what we discussed. Now again, whatever we have discussed with EV can further divide into two things. One is vertical and one is aerial. Okay, what is this? This is vertical and this is aerial. Because volume is itself is a multiplication of area and height. That means vertical means we can say height whatever is contacted divided by total height into area contacted divided by total area. And finally, we can say that volume, this multiplication will give us the volume contacted divided by total volume. So this is the final step. Okay. So let's suppose I am saying you just have a quick questions on this. So let's suppose my actual height, I have a reservoir with initial volume of 1000 barrel of crude oil, and through that it contacted for unit height. Write down the questions. Are you following me?
Yes, sir.
Yes, sir.
Writing. Okay. Let me write. This is not a standard question, but at least to familiar with you the calculation. So let's suppose reservoir with hydrocarbon of the volume 5000 barrel as a unit height and injected fluid is contacted in 5 feet square area, then produce 2000 barrel. What is overall efficiency for this reservoir? Just try this question and tell me the answer. Easy है बहुत,
2/5.
कुछ है नहीं. Hmm?
2/5
Hope this
होगा ना?
value, hope this value seems real. कितना?
2/5 होगा ना?
Any other answer for this? Or all are you agree with 2/5?
2/5.
Yes, very good. Actually, that's the only trap. Many times what happens when we read these kind of questions in GET, na, our mind start to think area is given there. So we have to calculate first the efficiency of this that aerial, and then we have to calculate the efficiency for that, and we will simply multiply that things. Okay. but it's good catch. Okay, so read the question carefully every time. Okay, and just tell me the value of displacement efficiency and that value separately also. Okay, I think values थोड़ा कम आएगा, but okay with that because just मैंने ऐसे ही रखा हुआ है. Okay, just consider, don't take it 5, take it 500. Okay, and tell me the value for ED and EV. Is it visible ना? और वो logo बीच में
Yes.
नहीं आ रहा है? Okay.
ईडी की वैल्यू होगी 4 आएगी, 4 ईडी की वैल्यू।
How can
ED
efficiency
4
1?
4 आएगी 4.
4? How
हाँ,
can it?
it's
How how can how can it is more than? Okay. Let me. Oh. Just tell me the volume of 500. अब इसमें से कॉन्टेक्ट हुआ है 500. 4 कैसे आ सकती है ब्रो?
सर कॉन्टेक्टेड एरिया कम हो जा रहा है. कॉन्टेक्टेड जो वॉल्यूम है ना, वो प्रोड्यूस्ड
ये
वॉल्यूम से कम हो जा रहा है.
तो 5 ही सही था ना? आई थिंक 5 से क्या हो रहा है क्या ऐसा?
नहीं सर, उसको
हाँ
बढ़ाना
सर,
पड़ेगा.
हाँ 2000 से उसकी वैल्यू ज्यादा ही होनी चाहिए ना सर।
2000 से ज्यादा होनी चाहिए.
ओके, तो जस्ट टेक दिस वैल्यू अकॉर्डिंगली. कितना लिखूं यहाँ पे?
3000.
3000 लिख दो सर.
3000 फीट स्क्वायर और यूनिट हाइट है तो टोटल एरिया हो जाएगा अपना. बिकॉज आई एम नॉट कैलकुलेटिंग ना, दैट्स द रीजन. मैंने ऐसे ही लिखा है, अभी माइंड में आ गया. तो 3000 फीट स्क्वायर है. ओके, एंड वी हैव अ हाइट इज इक्वल टू 1 फीट, यूनिट फीट है. ठीक है, तो ओवरऑल वॉल्यूम कॉन्ट्रैक्टेड इज इक्वल टू 3000 फीट क्यूब एंड कन्वर्ट दिस इनटू बैरल इज कितना होगा? 3000 डिवाइड बाय 5 पॉइंट होगा ना,
हाँ डिवाइड बाय
यस.
होगा।
और ये हो जाएगा कॉन्ट्रैक्टेड वॉल्यूम. कितना हो रहा है? और इससे ईडी निकल जाएगा. ओके कुमार, हैव यू कैलकुलेटेड दिस वैल्यू?
534.283।
Okay, try to consider 4 digit. Okay, in gate also. Okay, I'm writing 0. Not an issue. Okay, so ये
ये तो कम
ईडी
आ रहा
निकल गया. हाँ, तो कॉन्ट्रैक्टेड एरिया कम ही आएगा ना. ओवरऑल
तो
एरिया से कॉन्ट्रैक्टेड एरिया कम ही आएगा ना.
हाँ बराबर है, बराबर है।
Okay, and you can calculate that value easily by dividing, overall and divide by ED. Okay, ये ED नहीं था, EV था. करेक्ट. And you can calculate this by, so overall is 2000 divided by 5000, and you can write this value here. You can. Okay, so this kind of question can be asked in question examination directly based on volumes. At that time रटे हुए formula नहीं चलेंगे. Okay, just wait 1 minute. Okay, guys. So this is the reason intuition is important, because रटे हुए formula से you cannot calculate. Okay, अगर वो in terms of SW and in terms of FW, in if you have you have remembered the answer, remembered that formula in that form, then you cannot solve this question by that. So now, guys, you have a overall idea of this efficiency. Okay, correct?
Yes, sir.
Yes, sir.
Okay. So when we discuss frontal advanced theory, it is very important. We will derive, or we can say we will have a formula at that time, because if I will explain you right now, then you won't understand. But this efficiency will come again and again during these methods. So you have to identify whether this method is impacting on microscopic efficiency or macroscopic efficiency, because MSQ may be asked, like they may ask you which are the following methods impact on macroscopic but not on the microscopic. So that understanding is required. Next things we can discuss is mobility and mobility ratio. Definition for that. These are the terminology. Okay, you have to master on this. Then and then you will get more that. So after this session, try to read this from Tarek Ahmad. Okay, you will get these all things in Tarek Ahmad chapter 13 or 14. Which one, where this pattern and all is given? Can anybody confirm? Or you will find this? Will you find this, or shall I confirm the
Yes, sir. We
chapter?
will find this.
Okay, okay.
We will find.
Mobility, what is mobility and what is mobility ratio, guys? Anybody can tell me what is mobility? We generally represent mobility with lambda. So
K
what
by
is
mu.
lambda?
Mobility is K by mu.
Okay, good thing you know. Okay, mu know. I'm considering for oil, then this means all is for oil. Just tell me, is it a relative permeability or absolute permeability?
Absolute. No,
Did you read this? No, it's a relative. Okay, just remember this thing. It's a relative permeability of oil, and it's a viscosity में तो ऐसा कुछ होता नहीं. Okay, for water it change to. Okay, just remember this thing. Then what is the mobility ratio? What is the mobility ratio? Anyone may have idea?
I
Nobody
think
knows?
guess.
Hmm?
I think oil के हिसाब से water कितना move हो रहा है ऐसा कुछ हो सकता है.
Oil के हिसाब से water कितना move हो रहा है? Percentage of kind of mobility, correct?
हाँ, yes sir.
Yeah,
it's a
absolutely correct. What?
flow rate of oil upon water.
No, man, not at all. Flow rate of oil upon flow rate of
Flow
water.
rate of water. Yes.
No, this is not a mobility. This is simply, you can see like this.
Fractional flow or what?
Yes, it's a fractional flow. We will discuss that later, not now. But we can say mobility is a ratio of displacing fluid to the displaced fluid. Okay. Displacing fluid mobility divided by displaced fluid mobility. Okay. Or you can, based on this, you can say mobility of water divided by mobility of oil. If the case where water is displacing the oil, or in EOR, most of the, not most of the, all of the time, this is the common case. Okay. Remember these definitions because there are chances this can be asked directly. Displacing is on top, displaced in below. Based on definition, can you comment? Shall we have to keep? Okay. Just before these things, I would like to write this entire formula. If this is a formula for a mobility, can you tell me one thing? I have just substituted the value of this lambda w and lambda o. Can you tell me, shall I keep mobility ratio less than 1, equal to 1, or greater than 1? Or can you tell me what does it mean when it is a less than 1, when it is a equal to 1, or it is a greater than 1? And this is the questions which can be asked in interview directly as well as in gate. Also, again, it has been asked in gate more than 2 times, I think. So
आई थिंक सर लेस देन 1 होना चाहिए। तो क्या कि विस्कोसिटी, वाटर की विस्कोसिटी बढ़ेगी तो
yes,
वाटर
yes.
वो ज्यादा का उधर ही रहेगा, और ऑयल की परमेबिलिटी जो है वो ज्यादा फ्लो हो सकता है, मतलब उसकी बढ़ेगी तो।
Oh, oh, I have written this formula correctly, na? Just verified that. KRW by mu W, KR. Okay, correct.
Yes.
Okay, so you are saying कि when mobility ratio is less than 1, in that case, the water viscosity will go up,
यस
correct?
सर।
Or
यस
this value maybe, let's consider this value as a constant one. Just take a case of viscosity only. And this value may be consider two cases where water viscosity is high. So if water is heavily viscous, then there are might possibilities water itself cannot move. Okay, ऐसी possibilities हो सकती है कि
यस
जहां पे water ही इतना viscous हो गया कि water ही खुद move नहीं कर पा रहा है. In that case we will not get that much better recovery. But अगर ये दोनों equal है, water की viscosity and oil की viscosity, then it can easily push the oil. So m is equal to 1 means it's the best condition, but we consider it as a value. What we consider best mobility ratio is less than 1 but near to 1. What does it means? Can you understand it properly? Less than 1, best mobility ratio is less than 1 but near to 1. For an example, it should not be 0.2, 0.3. 0.9 is better than these values, okay? But let's consider 0.8 and 0.9, then 0.8 can be better one. There is no cutoff value, but nobody can directly ask this question. But if somebody is asking you, then always select these options. And in gate also, you just verify these things. M less than 1, like they won't give you option like this. They give you option like this only, okay? And they did same thing, okay? So just select this one, okay? And the reason already I think explained, and that is the correct thing you understood from formula. And always whenever this kind of questions comes, try to learn from formula itself. Formula can answer any questions, okay? Because model is ultimately representing the actual things only. Another thing, if m is greater than 1, that means viscosity of oil is high, but viscosity of water is low. Water is not able to push the oil. Simple. So this is important again. And in ONGC, they always ask this kind of basic questions at that time. Be a confident and like your voice should be strong enough to answer. And that is the only the things according to you can differentiate from the other candidates. Okay. So just consider this thing. Then next one is okay. So is it clear now? Mobility and mobility ratio.
Yes, sir.
Okay, so the next thing is mm, Tabor number. Okay, we will discuss the Tabor number in last capillary number. So do you know okay, capillary number and Tabor number? These two things we remained with. Then we will conclude the session. Mm, okay, nothing, anything else for today. So these two things we can discuss and we can conclude. So do you know capillary number? What is
No.
capillary number? Any idea?
Thermal diffusivity. नहीं.
What?
No, sir.
No,
सर
no,
वो
no.
diffuse
What?
वो डिफ्यूजिविटी के जो रेशियो होते हैं ना थर्मल टू मोमेंटम या
Thermal to momentum. Okay. It can be. Let's. It can be. Yes, it can be diffusivity ratio. But in basic terminology, we can say it is a ratio of what the ratio you told? Thermal to?
थर्मल टू मोमेंटम डिफ्यूजिविटी.
No, 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 no. That is, I think, Nusselt number. Or
अच्छा.
Nusselt or Prandtl number which you are discussing. I did not remember right now, but that you can get on production videos. Okay, just have a look into that if you don't know this all Prandtl number, Nusselt number, Weber number, and one more thing was there. You just look that because
ओके.
they ask once in gate examinations and it asks for 2 marks questions and that questions is in that pair kind of questions and in pair kind of question they do not have any clue. You should know all 4 numbers then and then you can answer. So in that case you it won't help if you know only one or two. So capillary number, it can be the ratio of diffusivity. I will think and I will give you like I will give you if it can be ratio of diffusivity tomorrow because it has a term related to that, or we can derive right now also which diffusivity does it counting. So let's suppose I think it's a ratio of R diffusivity which we use in well testing. Which one is? Which diffusivity we use? Do you remember or forgot?
इन वेल टेस्टिंग.
Yes. Name of that diffusivity, like thermal, which diffusivity we use? Its diffusivity, I think there is no any name. Diffusivity divided
यस
by
सर.
kinetic
डिफ्यूजिविटी
viscosity.
कांस्टेंट.
Hmm?
यस सर ओनली डिफ्यूजिविटी दे रोट
Yes,
इन
yes,
बुक.
yes. We wrote diffusivity, but it's I think related to this thing now. Okay, just leave it. Thermal diffusivity and this diffusivity. Diffusivity by kinetic viscosity, it can be formed this capillary number. We can say this, but just have a look. I'm not sure about this, but just have a look. Uh, so capillary number is a ratio of so before capillary number, do you know apparent viscosity and apparent velocity and actual velocity?
यस सर.
Can you define it?
सर मीन्स एक्चुअल वेलोसिटी मीन्स apparent velocity divided by 5 the porosity.
Okay. Yes, porosity. So we are not like when we derive that FFPM equation, we consider that and the flow is not from porous media throughout the entire that area, but later on we convert it for a porous media. So definitely based on the continuity equation, we can say that lesser the area, velocity should increase. and when velocity, we simply increase the velocity. So remember one thing, in capillary number, it is a ratio of mu v by sigma phi. This is the formula for that. And when we write v here, it means apparent velocity, or you can say it's a mu sigma by v actual. Actual, okay, correct. Actual means real, okay. Mu is the here viscosity of crude oil, definitely. V is the actual velocity, or its apparent velocity by phi. Sigma is here interference tension. Okay, when we say interference tension, then I should not define it. Okay, it's between that oil and water only. Just confirm it once regarding this sigma. It must be between oil and water only. And what we can say. So what is the equation for diffusivity? Do you know?
Well,
K by, yes, yes.
0.000 नहीं, वो तो कांस्टेंट है.
अरे कांस्टेंट चलो छोड़ो, K by, चलो it's
K
have
by
a some,
5 mu ct. K by 5 mu ct, I think.
okay, I velocity. Okay, then it won't be the ratio here. K is the velocity. Okay, just replace this K with Darcy-Lona. Replace this K with Darcy-Law. Then what it should be in terms of Q? Q by A is the velocity, and we can say velocity into viscosity into dp by L. Something we can write. Are you agree?
Yes, sir. Yes, sir.
Yes. And phi and ct already present, and viscosity. So this viscosity and this viscosity will cut off, and then it might not possible, but we can replace this row. Yes, 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 you were correct, I think. Yes, it should not be kinetic viscosity. It's the ratio of diffusivity to thermal diffusivity it can form. Yes, this is diffusivity. We can say this terminology. Okay. Uh, Based on this, how can I arrange this? But okay, just replace here now, so it would be easy to understand that all things. V into mu को हम replace कर सकते हैं permeability से and all. So we can replace this with. Okay, let's derive this because this can be asked directly. What is the ratio for it? And it is not hard thing. Let's suppose NC can be this apparent viscosity, and I'm just substituting this to with permeability. What we can write? Permeability dp by dl sigma phi. And remember one thing, they can ask you the question from here also. Let's suppose, just tell me for better recovery, which value you should consider, higher capillary number or lower capillary number. Based on the formula, you can answer it. Answer it, na? It easy. Hello?
Hello.
Yes. What should be the value for better recovery, higher capillary number or lower capillary number? No?
तो वो तो
Okay.
विस्कोसिटी और वेलोसिटी पे डिपेंड करेगा ना. अभी लो, हम
नहीं,
सपोज
नहीं.
अभी लो,
Yes, yes, yes. Go ahead.
अभी सपोज हम लो ले रहे हैं, मतलब कैपिलरी की वैल्यू, तो उसके हिसाब
Hmm?
से विस्कोसिटी कम है और वेलोसिटी भी कम हो जाएगी उसके हिसाब से. तो
विस्कोसिटी कम है तब वेलोसिटी कम होगी कि ज्यादा होगी?
ज्यादा होनी चाहिए.
For crude oil, okay, just let me tell you one thing. In terms of gas, it may behave differently, but for oil, let's suppose if viscosity is lower, then it can flow easily. Okay, is it correct?
Yes, sir.
Okay, so basically क्या हो रहा है यहाँ पे, velocity is compensating with viscosity. Have you got this? So based on sigma, we can say that if interfacial tension is lower, then it can flow easily. Correct? So higher the
Yes,
value is
sir.
better. Okay? Higher the value, it means higher the recovery. Consider this statement and remember this statement. Note down this with formula. Okay. And regarding to this formula, you can say many. You may have a many answer. Just remember this is inversely related to porosity, directly related to permeability. So this can be asked in MSQ. Okay. And like during my MTech, I during the MCQs, IIT professor asks question based on this. That means it may ask in gate question, gate paper. Okay. So just remember it's directly proportional to K, inversely proportional to phi and sigma. And we can say this is the ratio of, like if somebody tell you define capillary number, then don't say it's mu V by sigma. Just tell it's a ratio of viscous force to capillary force. No, not a capillary force exactly. It should be, you can say surface tension or interference tension. Okay. Just tell definition like this one. The next is, okay, so we are going to derive this. Mm, May I audible or may I disconnected?
Yes, sir. Yes.
Okay,
Audible.
simply I can say one thing from here is I can replace this. I just replace this K and uh, here we can say is sigma into L. If you think unit sigma into L can be neglect, we can neglect that. Correct? Sigma into L can be pressure, some kind of pressure. It may be related to that curve between two phase pressure or something kind that we can say based on the unit. Sigma into L is the pressure. This can cancel out. Yes or no?
Yes, sir.
Okay. Just multiplying density at top and multiplying density at bottom, and the compressibility term we can get, uh, let's suppose I'm multiplying above with like this is a dimension number, which means that it do not have a dimension, so we can represent it with different entity but with same unit. Okay, so I'm multiplying top with that thermal compressibility and uh, total compressibility. Okay, reservoir total compressibility. And remember one thing in that formula also, this diffusivity formula also, K upon I CT mu, this is total compressibility. Okay. And this is absolute, I think, permeability. Yes, I think it's absolute permeability. But just verify this thing. Okay. I forgot these things because I did not follow this well testing, but I will verify and I will tell you tomorrow. Okay. But this must be absolute, I think, because we define diffusivity for particular rock, not for a particular. Okay, I will tell you that things tomorrow. And if I arrange this thing, na, still I am confusing. Okay, just I will verify this tomorrow whether it is a forming any relation, because You know, thermal diffusivity is simply like we have a K by 5 CT mu, na? Same way we have a C by rho as the thermal diffusivity. This is our thermal diffusivity. C is the thermal, that thing, thermal coefficient, thermal diffusivity. Mm, Porosity we do not have only density with us. Or density can be produced, CT can produce, or viscosity we do not have. Okay. Got it. Yes, it can be because this is, I think, CT by, uh, if this is CT by that, na, rho. So, like, if I replace this viscosity by rho upon, rho upon, sorry, viscosity divided by rho is kinematic viscosity. Viscosity divided by density is a kinematic viscosity. Something kind this. Okay, I will verify tomorrow now. Why should waste time? Okay, I will verify tomorrow. I will give you this tomorrow information regarding this. Okay, so it is viscous upon IFT. Okay, and the last number is a Tabor number. Have you heard regarding this number before this?
No, sir.
Okay. So this is simple. There is nothing new. This is simply del P by L divided by sigma. Let me verify this thing from.
Sir, Prandtl number is equal to momentum diffusivity divided by thermal diffusivity.
Yes, that I know. Momentum by thermal will give you Prandtl number. Okay, then might not possibility this can form any that thing. But I remembered this, so I tried. Not an issue. We can skip that. But if something will ask you in exam, na, then you should remember this. What is thermal diffusivity? Okay, thermal diffusivity is nothing but C by rho. Or you can compare. Okay, whenever. Let me tell you one thing. Then I will. Okay, Tabor number we were discussing. Na? So let's complete this first. It's a del P by L divided by sigma only, or sigma by divided by del P by L. Let me verify Tabor number also. Hmm. So, are you guys feeling any difficulty to remember this kind of formulas, or because I had many difficulties. Most of the times they gave the formulas, but small formulas might not give you. Or you can search on Google also if you haven't made. I don't have that. Its a table number is del P by L divided by C. Okay, it's a pressure gradient. And sigma is the interference. These numbers are important, okay, guys. Then Anything else you remember to discuss, you want to discuss for today? Because I'm going to conclude the session.
Hello, sir.
Yes.
Can I stop the recording or continue?
Now you can stop because we have already, okay, we
Okay.
already done with today's session.